worksheet on section 1.6 and 1.7, and I'll do this in two parts. I'll try to do the basic derivative rules first, and then we'll go back and do the two application problems that are also included on this worksheet. In the first set of problems, we're using the product rule or the quotient rule, and so these are fairly easy to recognize. For example, this is clearly a product. You see a dot there, so this is something times something. And so our product rule says that the derivative of this should be, and again, I'll write out, oops, I meant for that to be a cube. So our derivative will, our product rule says that the derivative of this will be the derivative of the first thing times the second, plus the other way around. So, and I'm just writing out I'm writing out the rule first, and then I'll go back and actually do the rule. So this is what the product rule says to do. And so now if I actually find this derivative, this should be fairly straightforward. I'll just simplify it as I go. So that's 9x squared plus 2x minus 3. So that's the derivative of this piece. And then we're going to multiply that by the original second term. And then we add to that the derivative of the second term, which is 3x squared plus 8x minus 1 times the first term. So what goes in here is 3x cubed plus x squared minus 3x plus 7. So that's the unsimplified answer. It's not worth simplifying. It's be very time-consuming to multiply all of that out in combined terms. But if we did have to do something algebraically with it, like figure out where it's equal to 0, we would have to do additional algebra. And the second problem, this is clearly a quotient. It's something over something. And so the third bullet also is clearly a quotient. And so the quotient rule says that we have the derivative of the numerator times the denominator minus all over the original denominator squared. And so now when I actually find those derivatives, the first one there is 21x squared minus 17. So that's the derivative of that. And of course the derivative of x plus 1 is just 1. So and all of that is divided by x plus 1 squared. So again, algebraically it's a bit messy, but very easy to find the derivative expression. And so same kind of rule works for the next one. I'll have to have the derivative of the numerator times the denominator minus the other way around. And don't forget to divide by the original denominator squared. And so then we're just one step away from doing this. I just need to find the derivative of the numerator, which is 4x minus 17. That's multiplied by x squared plus 1 minus the derivative of x squared plus 1 is just 2x. And then all of that is my numerator, and it's divided by x squared plus 1 squared. So the quotient rule and product rule are very easy to do. They give us big expressions that will be challenging algebraically in the next unit when we have to do things with them. But for now, it's pretty easy to find the formulas. We're going to skip the practice 2 because both of those parts are word problems, application problems, and we'll come back to those in a different video. On this page, we're using the chain rule, and we've gone over some of these in class, but I'll document them here as well. The derivative of this thing, this is really just an expression, where I was drawing sort of a box around it. It's an expression to the fifth power, so the derivative of that is to apply the fifth power derivative rule, which is the 5 comes down in front, and the power goes down by 1. So this is the derivative rule for something to a fifth power. And the chain rule says that that's not going to be quite right. We have to multiply by the derivative of what was in the box. And so I was trying to emphasize in class that this expression is in there 3 times. It's in the question, original question, it's inside the power rule here, and then you multiply by the derivative of that. And so to finish the problem, all I have to do is find that derivative that's being alluded to, which is 15x to the 4th plus 8x. And then we can simplify that if we want to. The second problem is the same thing as asking what's the derivative of 1 plus 3x squared to the 1/2 power. The square root and the 1/2 power are the same thing. And so if you think of it that way, then it's really exactly the same as the previous problem. The derivative rule for something to the 1/2 power looks like this. The 1/2 comes out in front, and then the power goes down by 1. And what's inside the parentheses is just what was inside the parentheses before. And then we multiply by the derivative of what was inside the parentheses. So to finish the problem, I only have to work out what this derivative is here. Derivative of 1 plus 3x squared is 6x. And so again, I can simplify that a little bit without doing a lot of work, because 1/2 of 6x is 3x, and we can rearrange some things, but that's the unsimplified answer. Something similar happens with this one. We recognize that that third power in the denominator is the same thing as having a -3 power. And so, again, without taking a derivative yet, that's just the same expression. And so now my power rule can be applied. The power rule says that the -3 would come in front, and the power would go down by 1. And the chain rule tells us that we have to multiply by the derivative of what's inside. So in this case, the derivative of x squared plus 1 is just 2x. And so, again, we can simplify that if we wanted to, but that's a perfectly good unsimplified answer. In the fourth problem here, point out that you need both the product rule and the chain rule. And so the question is, what do you do first? And you just have to choose between them. We said in class that this problem does not look like this. It doesn't look like the derivative of a bunch of stuff to a power. Certainly that is part of the problem, but we would not be able to write anything in this box for a p and make that match that. They will not match with just writing something inside the box there. However, it does match the form of the product rule. The product rule works with things where you have the derivative of something times something else. And you can see that if I took this piece and dropped it in the rectangle, and this piece and dropped it in the oval, then this would look exactly like that. So this is the correct rule to use first. It's supposed to be a smiley face. So the derivative, according to the product rule, it's the derivative of the first thing. So x squared plus 1 cubed derivative times the second thing. Oops. Well, shoot, so that's a 3x minus 2 to the 5th plus the 3x minus 2 to the 5th's derivative times x squared plus 1 cubed. In other words, it's just the derivative of this guy times that one plus the derivative of this guy times that one. Now, to evaluate these two derivatives, I have a derivative here and a derivative here that need to be evaluated. Both of those look just like this. So each of these separately look like this, and so the chain rule will be the appropriate rule to use for finding that derivative and that derivative. So I'll go ahead and do that. The derivative of this piece is 3 times x squared plus 1 squared times the derivative of x squared plus 1. So this is what the chain rule says is the derivative of this guy. That's still being multiplied by 3x minus 2 to the 5th. So this part that was on here hasn't changed. I just moved it down to here. Plus, now I got to do it again. I have this derivative, again, by the chain rule. That's 5 times 3x minus 2 to the 4th times the derivative of 3x minus 2. All of that is the derivative of this piece. And I still have to multiply by this guy. So times x squared plus 1 cubed. So to finish the problem, I now have it down to I only need to know what this derivative is, which is just 2x, so that's not bad. I need to know what this derivative is, which is just 3, and so that's not too bad. So the unsimplified version of this would have 3 times x squared plus 1 squared times 2x times 3x minus 2 to the 5th plus 5 times 3x minus 2 to the 4th times 3 times x squared plus 1 cubed. So that's long and messy, and it can be simplified a little bit because I can certainly see that 3 times the 2x is 6x. That's easy to see, and 5 times 3 is 15. And there are some common factors. There's some common x squared plus 1s. There's some common 3x minus 2s. And so when a formula comes out in this form, we really will be able to algebraically simplify that quite a lot. But again, for this section, we're really just trying to learn the rules and not worry about it yet. In the next section, we'll start to see times where we need to do something with these answers. And at that point, we'll need to be able to do the algebra.